Okay. Sorry. Let's look at this question. It says that Asiedua opens an account that pays an annual rate of 6%. Annual rate 6%, sorry. Annual rate of 6%, compounded continuously with an initial investment of this. So annual rate, so that's rate goes to 6% is equals to 6 over 100 goes to 0.06. Now, compounded continuously with an initial investment of this. Initial investment. So if we say if P is balance, then P naught is equals to 5,000. In other words, at T equals 0, P of 0 equals to 5,000, like this. Okay. Now, after that, she deposits an additional 1,200 Ghana cedis per year. So she deposits goes to 1,500. Sorry, 1,200 per year. Assuming that no withdrawals are made and she continues with the same yearly deposit over 10 years, how much will be in the account at the end of the 10 years? Good. So we needed how much she will be having in her account after 10 years. That is all the question. But here we know that the differential equation modeling this kind of question is given by dp dt goes to rp plus d. Y plus d. Here r here indicates the rate, p here is the balance. Now the d here indicates the deposit. So since Asiedua deposits 1,200 already, then that will be part of her balance in the bank. And then this rate times the balance indicates the change. So if the rate change, the balance changes. So we now have this part for her money increasing, or in other words, the interest or any other thing, now plus the deposit, like this. Now this one, and then let's see at p of 0 we will have 5,000 Ghana cedis. P of 0 is equals to 5,000. Now we can then rewrite this. We know that the rate is 0.06, like this, and then the deposit is 1,200. So we just have to replace them for our initial, the IVP. So we now have dp dt goes to the rate 0.06 times the p plus the deposit, which is 1,200. Now the p of 0 is equals to 5,000. So here we now require to solve this IVP. Good. So now let's see how we are going to solve that. Of course, we now have dp dt goes to 0.06p plus 1,200, like this, which implies that we have dp dt minus 0.06p goes to 1,200, like this. So this is our standard first order differential equation, which we can solve by either way, or we have two methods by solving this. We can either use the integrating factor approach, or we use the method of undetermined coefficients. Anyway, I prefer using the integrating factor approach because it becomes shorter for you. So here we'll just have to identify. We know that the integrating factor is given by mu. Here the variable of interest, sorry, here is r, sorry, p, okay. The variable of interest is the t, so mu of t goes to e power p. Here in the formula is always p of x, but here it will p of t because, and now our p of t in this case is this value here, negative 0.06. So negative 0.06 dt, like this. And so integrating, we have e power negative 0.06 t, and this is our integrating factor. We then use this integrating factor to find our p of t. We know that our p of t is equals to the integral of this value 1200 times the integrating factor, which is e power negative 0.06 t. This is, we are just writing the solution plus c all over e power negative 0.06 t, like this. And so if we integrating this part alone, we are going to get we will keep this here. This one is a constant, it can just come out, but here we have to integrate this, and the integral of this one will just be, we'll keep the whole function and then we differentiate the power and divide the function by that answer. So, and in other words, we have e power negative 0.06 all over negative 0.06 t all over negative 0.06, because when we differentiate this one with respect to t, you get negative 0.06. And so dividing 120 by 1200 by negative 0.06, we get negative 20,000 e power negative 0.06 plus c all over e power negative 0.06 t. Sorry, here's t. So, and this one will become this one is dividing this part and is dividing this part, so this one will cancel this part, you get negative 20,000, and here is negative, so when it's coming up here to positive, plus c e power 0.06 t, like this. So that is our p of t. So our p of t is equals to negative 20,000 plus c e power 0.06 t. So this is our p of t, but we are not done. We need to find c using the initial value. We know that at t equals to 0, we have p to be equals to 5,000. It was given, they said the man, I said the word deposit 5,000 initially, so that was it, and the initial deposit was 5,000. But this one was also there, so initial deposit was 5,000. So that will imply that we now have p of 0 to be equals to negative 20,000 plus c e power 0.06, where 0 equals to 5,000, like this. And so we will now have c e power 0 to be equals to 5,000 plus 20,000. We just send this across, and so we have c to be equals to 25,000. This is our c. So now we then rewrite our balance function, which will be P of t to be equal to the C is now 25,000. So we have 25,000 e power e power 0.06 t minus 20,000, like this. This is minus, so you can rewrite it this way. So this is our P of t. This is our P of t. But we are asked to find when the time when t is equal to 10 years, how much will he have in the account? So this is what is modeling what he will have in the account. So we just go ahead and say at P of 10, what will we have? 25 e power 0.06 of 10 minus 20,000, like this. And when we do this, we are going to get approximately 25,552.97, and so this is just 25,552.97 Ghana cedis. This is what he will have in the account after 10 years. Okay, thank you for watching. Kindly subscribe. Before you go, subscribe.